All right. So a couple other things we're going to talk about in this particular chapter, and we start introducing you to. And some of you may have already had some experience, but we're going to look at how software is developed. If we're going to play in this field a little bit, we need to have some ideas about how it's going to work, and it's very similar to what we're going to do on our own coding as we go through here. So there is a model, and we talk about it in a lot of other courses, something called the waterfall model, which says we figure out what the customer wants, we analyze it, we design it, we implement it, we integrate it into what their existing system is, and most importantly, we have that idea of maintenance. In other words, there's going to be updates and things that need to happen. So it's changed a little bit over the last 40 years. Software used to be kind of a very cumbersome process where you had time to do all these steps, and it was a one-shot through. Maybe you decided we're going to develop a new system for our accounting software at our big, large, giant corporation. Takes 4 or 5 years. That works. Now, the world has changed around us a little bit, and we need to have a very iterative, very fast coding cycle so that we can stay ahead of our competition. So think about the people that are designing game software for iOS phones or Android phones. And think about how quickly they need to put that into place. So now we have this idea we break it into smaller increments. And when we say we iterative, that means it continues over and over several times. So you have this waterfall model shrunk down to smaller stages. And then we typically build some prototypes and we implement our software in stages or in smaller and smaller pieces. So you'll see that that trend is changed by what's happening around the world. We don't have time to build a 3-year plan now to change our software. Our world has gotten faster and faster and faster. So while this is ideal in some cases, by the time we get all the way through the waterfall traditional method, the original need has changed. So if we're developing software for an iPhone 8 or 7 or whatever used to be available a couple years ago, that model has changed and fairly quickly, and so we need to adapt to that. So you'll see we're going to move and change a little bit. Part of that is this idea that programs rarely work the first time. And you're going to find that out as we start coding some software. You're going to be, oh my goodness, I can't get it to work. And at some point, you're going to have to do some careful testing. You got to make sure that the items work correctly. But I think this chart is applicable to a lot of things, and we'll talk about a couple of them. But if I look at those stages, by the time it gets all the way to the maintenance stage, if we have a serious issue, it's much more expensive to fix. Well, compare that to a car being made on an assembly line. If somebody puts the wheels on the car wrong at the factory, it's fairly easy to fix. And again, we're in that analysis stage if you think about that in terms of a factory. By the time it gets to the dealer, it's more expensive to fix. By the time it gets to your house and they have to do a recall, that's a lot of money. So we want to get these things done right first, but we know that there's always going to be issues. Look at Microsoft Windows as a good example. Look at Microsoft Windows. Every couple of weeks you get all these updates because they've discovered there's more and more bugs or unintended features or whatever you wanted to call them that nobody could think of at the time. Because with Windows, one of the difficulties is there are millions of different permutations of hardware, software, and other things existing on your computer. Well, Mac still has updates, a little less frequently, a little less massive in most cases, although some of their updates have been fairly generous. But one of the advantages for the Mac is it's a known quantity. There are only so many different types of Macs being made, so the developers have a little easier time testing as many combinations of those things as possible. So in this case, what it's showing though is their model here, 70% almost of the cost of that software development is in that maintenance phase. So even though we design something, we build it, we implement it, the cost doesn't end because we implemented it. We always have those changes, we have updates, we have pieces we need to do. So that maintenance phase can certainly be the most expensive aspect of what we're going to do. Well, we're going to lead into looking at something called a string. It's chunks of text. Well, if you think about your own daily life, what's the most common thing you're doing? You're usually on a word processor. Especially as a student, we're making you write word problems all the time. So all of these things rely on characters or pieces of text. So email, word processing, text messaging, behind the scene, things like Twitter. All of those require text strings. So we need to talk about a couple of different types of data that we have available. So we have a couple of different numeric types, and this is one advantage to Python compared to some other languages. In some languages, we would have 6 or 7 or 8 different data types because we could specify not only were they an integer, but we could specialize whether it's a little integer or a big integer. In other words, how far away from 0 we can get, either positive or negative. Python says, now we're just going to have 1, and we're going to call it an integer. So an integer is a whole number. And then a float is what we're going to call a number with a decimal in it. And again, in a lot of other languages, we have to specify how many digits that number is. Python does a lot of that work for us. So integers, so floats, all those things. And notice we can do both negative and positive numbers. And then this idea of character strings. So a character string just says, hey, I'm going to put in something, and I don't care what it is, and I'm going to have it in a box, and I'm just going to hold it for you. So character strings are great. We've already figured out, though, you can't do a lot of math on them. So even though we have a 66 there, I can't multiply it by 2 unless I convert it or change it from a character string to one of either an integer or a float. And so those are the major types of numbers we're going to work with. So strings, though, there's some really interesting things. We've all used the quotation mark already. So you've enclosed that quotation mark to say that. But one of the things that's interesting is we can actually use double quotes to enclose a single quote. So when I do something like, go backwards. When I do something like this here and I want this single quote in here, if I enclose that in double quotes, it'll actually print out correctly. Well, I'm like, well, that seems weird to me, but I can always go into this idle environment. And that's one of the reasons I like having this around. I don't have to go into Cengage. I can sit here. I don't even need internet connectivity. And I can say, all right, well, let me see if that really does work. And so I'm going to put, I'm using a single quote. And let's see what actually prints, because we're at this. And it actually will allow us to print that single quote. So in a lot of cases, we can use these interchangeably. So I could write a print statement, and I could say, in a single quote, melts the snow, and it will print fine. So in a lot of cases, the single and the doubles we can use interchangeably. What is really interesting, though, is we can actually use 3 single or 3 double quotes for multi-lines. So we can create a text statement that extends over multiple lines. So I could create one that looks like this guy by just using a print. And now I can create some text. And it hides it in there, and if I put the right, and notice it actually prints on multiple lines. It does that really nicely for me. So If I have a lot of text to output, I can use those triple quotes to do that. The other thing we need to look at is Python allows you to put in some functions embedded into my text. And the first time you see this, you're going to think, well, this is really weird. So I'm going to bring up my friend idle again, just because it's handy to have here. And one of the things that we can do is in a print statement, it's really handy sometimes if we want to move a line down. And we can do that. Let me flip to that one. So you can see our chart of lines. So we have these, they call them escape sequences. And so we use this slash new line a lot. Because what it'll do is allow us to put things on a new line at some point down the character string. So I could say, and now I've actually got 3 lines down. So it looks like it's in that string, and then enclosed in the quotes, and you would think, well, it's going to print. But when I do this, what it actually did, and you can see it moved down 1, 2, 3 lines, and then printed my statement. So if I'm just at the interactive shell here, that doesn't do a whole lot for us. But combining these guys together, we can manipulate our text all over the place. And in fact, we can enclose double and single quotes inside of those escape sequences. So even though it looks like it should print out that escape sequence, it doesn't. And so it's one of those weird things about Python. So it allows us to put that new line right in there. And I could put them at the end also. So I could come in here and change that a little bit. And so I could say, oh, hang on, I got to recopy that. So I could put them at the end. And then I could do the same functions, and I could put them at the end. So that's one way we can move text around. And so now it didn't put them at the beginning; it put all those blank spaces at the end of that. So we use the new line a lot. We use that a lot. So be prepared to see that quite a bit. There's a couple of other things that are really handy inside of Python that make it so much easier than most other languages. So let me get back over here to my idle. See if I can get it to where you guys can see it again. There we go. All right. So strings can be combined. We can actually use the plus symbol, for example, to do something what we call concatenate, but really what we're doing is adding these strings together. So I could say print hi and I could put those together with plus signs to create a new value or a new item. So the plus signs are a great way that we can combine data. Even more interesting is we can do things like this, where I can build in functions. So I could say print Vader, and I could actually use the asterisk or the time symbol, and notice what it did. It printed Darth Vader 10 times. And I know that's down at the bottom and probably hard to see here. Oh, didn't want to make it that big. Go back here. So it printed that on several lines. So if I wanted to do that and actually put each one on a new line, I could modify that just slightly. Print, come on, go to the bottom line. this way. There we go. So get to the bottom line here, and so I could do a print. My name is Boba Fett, and then I put in a new line character, and then I multiply it times 100. So in a lot of other languages, we could do the same thing, but it would require us to build a loop that we're going to talk about in the future, and it would certainly not be on one line. And in this case, my idle actually said, oh, you wrote it too many times, so now it did what this squeeze text. So it put it in 100 times, and it did it all on a new line. So it really is very powerful, the ability to run strings inside of Python. We don't have to do a lot of other things with it. So there was some confusion. I had some people talking about or asking questions about how to do variables. And inside of our item here, or our shell, I can create one. So I could say name is equal to Princess Leia. So now I've created a variable that says this is a name, and we assigned a value. So if I printed name, it holds it in there and says, oh, yep, you're talking about Princess Leia. Well, those values we're going to start with, or these variables, we have some typical rules. And so these are typical for most programming languages. So what we like to do is make them descriptive. So in our case, name is pretty descriptive. They are case sensitive. So if I actually said print name, it's going to give me an error, because name with an uppercase letter is not the same as all lowercase name. And so you're going to get it's not defined. So one of the most frustrating things we're going to see is you start to type things and you put in a capital. They have to be identical. So we can put numbers, we can put digits, we can put all kinds of things, but it really has to start with a number. There are very few in Python. So a lot of languages, there's reserved words because we're going to use them for some other things. So if statements, defining functions, import, there's a few others, and it'll generally pop up. So if I tried to say def equals, and in fact, as soon as I type def, notice that it turns orange. So it's indicating that it's something different. So if I instead use dead, it doesn't change color because it's not a reserved word. So we could use dead as a variable, but we want them to be descriptive. So there's always a balancing game between descriptive and how long it is. So most of the time we write them with multiple words. We can't use spaces. Spaces are bad because the computer reads that and says, oh, I found a space, I'm at the end of this function. But we can use something called camel casing. So camel casing says name something like this equals mark. So in here, that function runs, and I now have a variable called name for the main character. I can see it very easily that what it is. I don't have any spaces in it, and so we've now assigned name for the main character. Now that's probably a little long, but that's one way we can break multiple words up so that you can easily see them. The other way that some Python programs are written in, and I don't particularly like it, but it actually will work, is I could do the same thing and I could say name underscore for underscore the underscore main underscore character John, and that would also work. I don't particularly like the underscores. I don't know why, just a weird quirk. I prefer just doing camel casing. But here's what will be very confusing. When you start coding, you want to pick something and stick with it so you're consistent in your own coding. If you're working in a company and you're altering some code and they've used camel casing and you come in with underscores, somebody's probably not going to like that very much. But typically the camel casing seems to be the most common. You want it descriptive, but yet not so long that it's cumbersome. You can actually make these 256 characters long. Well, when you have to type them and work with them, that's not very proactive. On the other hand, if I just did Z equals Stan, well, that works, but Z doesn't tell us. When I'm reading my code and I'm coming back a couple of months or somebody else is looking at my code, it doesn't tell me much about that other than, let's see, Z is, Stan. So it doesn't tell us anything. So we like them to be descriptive. I like them to be in camel case, but underscores are fine. So typically, we start with a lowercase letter, and our variables start with lowercase letters. One of the things that we can do, and I know that we have at least one math major in here, we use something called a constant. So in other words, if we're in chemistry, what's a famous constant in chemistry? She's like, oh no, Planck's constant. All right. She's like, oh, I didn't know there was going to be a test. Oh, but I figured you'd already taken chemistry. All right. So, but there's constants in math too. So pi is a number that we all represent. Well, in Python, we use the form of a constant, and so typically constants are all uppercase. So we say, oh, yeah, tax rate and deduction, those we're going to use as constants. They're not going to change during our program. Here's where it's a little strange compared to other languages. Most other languages actually have constants. We're just adopting the form of them. We can actually change them. And so that sometimes can cause us some issues because we accidentally change a constant. So we'll declare a constant and set its value at the beginning of our program. If we do it in all caps, we should be thinking, oh, it's a constant, we're not going to change it. But maybe it is an advantage that we can. So think about tax rate. Do tax rates change? Unfortunately. So standard deductions change, all those kinds of things. So when we create our statements, that we think about those as a constant for that program, for that time that it's running. So, what do variables do for us? Well, one really important thing they do is they let us keep track of stuff. And in fact, what I like to do is there should be no mystery numbers in your code. In other words, I don't ever have just a 0.07 in my code that tells me a tax rate, because that doesn't tell me what it is. So we call them mystery numbers. So it lets us keep track of what's going on in our program. And it also has this ability to abstract us. So we can look at the big picture and not get bogged down with a smaller item in there. So it's called abstraction. So we have complex data represented by a very simple variable. So when I say your tax payment for the year is, and tax payment is my variable, that represents something pretty complex, all those calculations. But to us it's abstract now because we're just referring to it as a single tax. A couple other things we want to look at really quickly, and that is, how do we document our code? So we want to make it as self-documenting as possible, and that's using those variable names that are consistent, that are descriptive, no mystery numbers. But we also have a couple of different ways we can document a lot of information. So our friend, that triple quote string, we can put a whole lot of text in. And we could put it in a multiple lines, and we could say, what is the purpose of this program? What is it supposed to do? And that way when somebody else looks at that code, or you look at it a year later, we always have that idea, man, I'm going to remember exactly what I did today. And then a week later you go, I was working on something. I can't remember what it was. What was I doing? So triple quotes for some long comments. Typically we use those at the beginning of a program. And then we actually have another type. We can actually put these at the end of a line to explain something. So we can do the number symbol or the pound symbol, and we could say, all right, so rate equals 0.85, and then we could say, all right, but this isn't going to display anything on the screen, it's just embedded in our content, is the conversion rate for Canadian to US dollars. So it's a quick way that we can explain content and what's happening. So the other way we can do that is we can actually use that same symbol, that hashtag or pound sign, at the beginning of a line. And one of the ways I use it a lot is when I'm troubleshooting. Because if I have a line that I think is problematic and not working correctly, I can insert that pound sign all the way on the left, and it's not going to do anything. It kind of cancels out that line from running. It turns it into a comment. And so we use it for some troubleshooting. So comments, you want to have what it's doing at the beginning. You want to explain what the variables are. So sometimes that's a great thing at the beginning. You have like a dictionary almost of all your variables. Major sections of coding. And if you have something that's odd or doesn't seem straightforward, explain it. The more comments, it's not going to hurt you later on. They don't really slow down Python. They just get skipped when the program actually runs, but it can make life a lot easier. So what I'd like to do here is we're going to dive into this just a little bit, and we're going to look at this idle shell a little more. So this isn't as useful. So I can do things like, print Stan or Z or whatever he is there. But this isn't a very comfortable way to write a program. It doesn't give me any way to store it. It doesn't give me any way to edit it and rerun it very easily. So what we're going to do is I would like you to come up here to the File tab and click New File. And when I do that, naturally it pops up in my other window, but I'm going to drag it over here. And so it gives us a new blank file. And it looks very similar, but there's a few differences. So I don't have these little quote strings, those carets pointing at me. And at the very top, it doesn't say anything about version or anything else. It almost looks like a text editor of some case. And in this case, it actually is. There's also some options up top here. So you get a run option. So we can run our string. So we can configure and change some pieces of it. We can formatting. And you'll see here fairly quickly these indents and unindenting or dedenting become important for us. So I've got a brand new file here. This is blank. And so one of the first things I like to do is I like to say something about what it is. So I'm going to use the triple quotes, and I'm going to say, this is my first program in the wild, not in Cengage. And for this class, what's really, really handy when you start working on these is putting in things like your name. And any other information I can do today. And then I'm going to close it with that triple quote. But I'm going to go the line below it, and I'm going to put a triple quote in, just because I think it looks a little neater to do that. So I haven't written any code that actually does anything at this point. Great. We're kind of getting somewhere. We have our first program. Well, in Cengage, it just kind of stores it for us, and we don't have to worry about it. In here, we're going to actually save our own program. And so we're going to save the very first one here. And notice it even says right now it's untitled. It means if my computer shut off, it was gone. I wouldn't have any way to pull this back up. So I'm going to click File, and I'm going to go Save As. Save works also. Here's where it's a little odd. So in Windows, it always wants to go back to this folder where Python is stored. Well, that's not where I want to go looking for my Python file. I typically want to put it in Documents, and maybe I even want to go and make a new folder. Programs, CMIS 210. So I'm going to make a new folder for it even, and then I'm going to give this a name. So I'm going to call this one first. Down here, it's going to save it as a Python type of file. So it's either py or pyw. Typically, it's py. So I'm going to save this. And if I were to go look for this file, so if I open up a file explorer here, and I come into Documents, I see my Python programs here, and I see this program called first.py. And notice it's got a strange little symbol, and Windows even says, hey, it's a Python file. So we're actually created our very first Python file that lives outside of the world. Great. So a couple of things about these out in the wild. So one thing I'm going to have you do, and our book doesn't have you do this, our book doesn't talk about it. At the very bottom of our code, I'm going to have you put in something like this. Input lost my cursor there. Press any key to exit. Now, I could do some other things, and I probably should put some new lines in front of it or something. So maybe a couple of new lines in front of it. What this does is this will actually keep that program from closing because it's going to wait for you to put in some input. And you're like, oh, that's weird. What do you mean? So let me show you here. So if I click Run, which is also F5, so it says, oh, any changes I've got to save. Okay, I'm okay to save it. And now it runs. And what it did is I got my new lines, and then it says press any key to exit, and now it exited out. So it holds that program up running. Well, inside of my shell, that's not very important, or it doesn't seem to be. But I will show you why it's important. You can run these programs without having that idle open. If I just double-click on this program, it's an executable program. And let me bring it over here, and it says press any key to exit. And when I do that, watch what happens. That window closes. If I don't have that open and I run this, it's going to open, run, and then close, and we won't even see what happened. So when I create my own programs, this is kind of an important piece. Let me drag that off the screen there. Is to put in this blank input at the end. It doesn't do anything other than keep the program available for me to see. So as an example, if I were to do a print statement here and said, this is my first program, new line times 10. So now if I run this program, so I hit the F5 or the run, I'm going to save it, and notice what it did. It ran inside of here. However, if I do it from that document here and I click on it to run it directly, it looks like this. But again, it shows me my lines, and then as soon as I hit that exit key, boom, it disappears. So this is just a quick and dirty way to keep that window open. A little cheat sheet, as you will. So We're going to find a place to save these files. The name is important. It will automatically add that extension .py. This idle shell is one way we can run those. We can run that program directly. And in fact, we're going to show you, and not today, but we're going to show you here in a little bit some other options for editing your software. So if I wanted to edit this program, let me find wherever it's at. Where are you at? There we are. I can actually open this in other applications. So notice I can edit it with idle, edit it with Notepad. I can open it with all different kinds of apps. So I could even open with, see what else looks. So if I wanted to open it in Notepad, I could even do that. So here, drag along, come along. So there's that same program in Notepad. So we have a lot of editing choices. If you go to the command line and you like VI or Emacs or some of these other editings, you can do that. But that program, though, has a couple of those requirements. So we're going to look at our assignments for this week really quickly. So this is just a video. This is a review of the quiz that's a little further down. There's a crossword puzzle. No points, but it has some concepts. Another review. So this is essentially that PowerPoint slide, but without me talking, which may be better. We're going to work through this coding lab assignment on Tuesday in class. And then we have these programming lab assignments that, thank you Blackboard, always end up backwards. And so I apologize for that. But it has to do, tries to organize them in order. So you always want to start with the lowest one, which in this case is 2.1. There's another, again, a video. We have some data files, but you don't need to do those yet. And we have another assignment, and that assignment is going to be, we're going to have to turn it into Blackboard as a PY file. So don't panic yet. We're going to start into that on the beginning of next week. So these go in order, and if we look at this, some of these, where did it launch? There it is. So, and I have not heard anybody, it does take a while to get in, but I have not heard anybody get stuck as, oh, well, that's not good. Hang on a second. Just when I was going to comment that I haven't had any Cengage issues from students, try this again. Ah, success. Okay. So this particular one says we're going to edit the code. And so sometimes this is a good way to do it. So this is that, notice it says taxform.py file. So that's our actual file name. So these look a little different. To run this, I click the little run button over here. And so it says enter your gross income. I made $100. I have one dependent. And it says my tax is, in this case, it actually says I get a refund, right? A negative number. That would be nice. So I want to look at this program really for just a second here. And I want to see what we're looking at. The calculator program of a 2-point digit. Use the round function to modify the program to display at most 2 digits. Here below is an output of the program and what it should look like. All right. So in this case, this program says, I'm going to call it taxform.py. Notice that's all triple quoted. And all of this is all a big quote. So it's telling you what we're doing. So constants, inputs are computations. So here we have our constants. And so notice we used a hashtag or # here to put that in as a comment. So it says initializing the account. So we set tax rate as equal to 0.2. or 20%, standard deduction as 10,000, and a dependent deduction at 3,000. We get this income, so that's where we take this, input, enter the gross income, and we automatically convert it then. We use that float to convert it to a floating point decimal. We also then get an input for the number of dependents, and we use an integer for that. So integers take less space, and we know that they're a whole number. Most people don't have 2.5 children. They really don't have that quite thing. And then down here we have their formula. So we created a new variable called taxable income, and we're assigning it the result of this computation. So gross income minus the standard deduction minus the dependent deduction times number of dependents. Oh, all right. So we've wrote a formula. We also then say, so income tax equals taxable income times tax rate. So this value here, after we took off your deductions, becomes your income tax rate. And then we output that. So the income tax is $. So here they've done something interesting. They've taken that income tax value and used that conversion to convert it back to a string. Now, let's see what happens if we do it without that string. We saw how it worked before, so it looked like this. So let's see if it actually works any differently. Oh, line 38. Unexpected end of file while parsing. Oh, hang on. I don't need this one. I have an extra. There we go. All right, now we'll try it again. Enter the gross income, so we'll do 1,000 again. We have 10 dependents. Now it's going to say, line 37, print the income tax can only concatenate. So here we're actually using the plus sign, and we're trying to combine those two, and that's where the error is going to be. However, I could do this, and I would end up with, well, we'll show you. Enter the gross income. And notice it will give me a value that way. So there's multiple ways to do these. There's not just one single way to do some of these programs and these instructions as you go through there. So in this week, you'll see that I've listed some assignments in here, so you've got a few things to do. We're going to work on this one together on Tuesday, and we're going to also work on this assignment here. So I have not fleshed it out because I don't want you to start it yet. So on Tuesday, we will get those pieces and start on that. All right, so I would encourage you to look at something like the videos. Make sure you're reading the content in the chapter. It's light and easy to read and amusing, or it'll actually put you to sleep. So this one explains the software development life cycle probably a lot better than I ever can. So make sure you use those resources. If for some reason you have not completed all the assignments from week 1, please go in and do them. I will take them till the end of this week. So that is this week in a nutshell. There is a discussion board that is due this Sunday, and that discussion board here is you're creating a repository of informative sites. So you need to find some kind of a tutorial, some kind of a help site for Python, and that would be a great thing. So make sure that you post the site name in the header or in your title. I've even spelled out that it's a punishable offense. I probably wouldn't be that horrible, but I would like everybody to come up with unique and individual assignments. It makes it a little harder if somebody logs in and they just see all content and no title in there to make it very descriptive. All right, any questions? Does that seem horrible? Dang it. I did not make it long enough then. I will add more stuff. All right, so we are supposed to have freezing rain and fun stuff this weekend, so hopefully that will go well for us. out. Why is it not giving me my pop-up? Pop-up.